welcome back to Elementary Algebra. I am your instructor, Amy Fuchs-Steiner, and we are going to be looking today at multiplying monomials. Let me say that again, multiplication of monomials. There we go, that's a little bit better. We're going to start with a multiplication of a monomial by a monomial. And for those of you who don't care for the fancy vocabulary, that means we're going to multiply one term by a second term. In order to do this, we are going to multiply the coefficients. And then we're going to multiply the variables. And as you may recall, when you multiply the variables, that means the exponents get added. All right, so I've got a few examples for us here, and we'll take a look at these. Problem number 1, we have a 3x to the 4th times a 2x to the 7th. As a quick review, our coefficients here are the 3 and the 2. Those are the multipliers of the variable terms. Our variables for both of these terms are x's and x and an x. And then our exponents themselves are the 4 and the 7. So when we multiply the monomials, we quite simply multiply the coefficients. 3 times 2. Let me run this process out for you. And then we multiply the variables. So then we'd have x to the 4th times x to the 7th. The 3 times 2 is 6. X to the 4th times x to the 7th is x to the 4 plus 7, or x to the 11th. And that's it. That's how you multiply the two monomials together. All right. Now, do we make this a bit extra sometimes? Of course we do. Of course we do. We're trying to check your skills and make sure that you can apply them and extend them and all that kind of fun stuff. Oh, those markers just keep rolling all over the place. All right, so problem number 2 is a little bit extra. We have coefficients of a -2 and a 3/2. So I'm going to do a -2 times 3/2. And yes, I am writing out more than you would possibly need to. And then I have a t to the 5th times a t. And I also have a w squared times a number. We have a w squared times another w squared. This is going to give us a -3, t to the 5 plus 1, w to the 2 plus 2. So a -3, t to the 6th, or w to the 4th. All right. Great. What do we do when there's 3 of them? Same thing. We just have more, right? So my coefficients here would be a -4 times the 2 times the -3. Then I have a y to the 5th times a y squared times a y to the 1st, because there's no power on that one. And then I'd have a z to the 3rd times a z squared times a z to the 1st, again, because there's no power there. So -4 times 2 is a -8, times a -3 would be a 24. Y to the 5th times a y squared is y to the 7th times one more would be a y to the 8th. A z to the 3 plus 2 plus 1 would give me a z to the 6th. And then I have a 24, y to the 8th, z to the 6th. And that would give me my new monomial. Monomial times a monomial is going to give us another monomial, as long as we simplify correctly. All right, problem number 4 looks like a lot, but really it's no more than we have been doing. Here we have a fraction coefficient of 2/3, so this will be a 2/3 times this coefficient of 15, 2/3 times 15. I have an m to the 8th times an m to the 1st here. No other ones. I've got an n squared times an n to the 6th. Now I've got some p's. We'll do p in purple because it's purple. This would be a p to the first times a p to the ninth. And let's see, I can, without a calculator, do 2/3 of 15. If you need a calculator, feel free to grab it. 2/3 of 15 would be the same as 2 times 15, which is 30 divided by 3, or 10. M to the 8 plus 1 is m to the 9th. N to the 2 plus 6 is n to the 8th. And p to the 1 plus 9 is p to the 10th. This gives me 10 m to the 9th, n to the 8th, p to the 10th. And I'm done. All right, multiplying monomials. All right. Sometimes we will multiply a monomial by a polynomial, meaning one term gets distributed. So what is our strategy here? Distribute. We're going to distribute, and we're going to multiply each term. And then we're going to simplify. Now, if you've practiced enough with this part will go much faster. So, here we go. I've got a 2p cubed times a 3p squared. Coefficients would be 2 times 3, which is 6. P to the third plus 2 would be p to the 5th. I'll do the next one. I should have done that in the color. That might have made more sense. For the second one, I've got a 2p cubed times 5p. This is a 2 times a negative 5, which is a negative 10. P to the third plus 1 more. Ooh, there we go. That's going to be a p to the 4th. And then for the last one, I've got a 2p cubed times a negative 6. That's going to be a 2 times a negative 6, which is a minus 12. And there's no variables here, so this p to the third just stays. That's not going to change that. And I have distributed. I cannot combine anything because that's a 5, a 4, and a 3. Even though the variable is the same, the exponents are not, and therefore they cannot be combined. Here I have a 6x squared minus 9 times a negative 3x. I am going to distribute. So I'm going to take that minus 3x times the 6x squared. This is x to the first, so I'm going to put that in there so I remember it. There we go. Multiplying my coefficients. I have a negative 3 times 6, which is a negative 18. I have an x squared times an x, which would be an x to the third. Then I have a negative 3x times a negative 9. Negative 3 times a negative 9 is a positive 27. And then this has an x to the first. This doesn't have anything. So that's just going to be an x. So I'm going to rewrite it. Negative 18x cubed plus 27x. It is in descending order. So I'm good to go. I'm done with that one. Boy, these markers are rolling all over the place this afternoon. Okay. All right. Now we're going to talk about multiplying binomials. 2 terms and 2 terms. We haven't done this yet. There are 2 different strategies. The first is known as a double distribution, and the second you may be familiar with, and that's FOIL. My preference is double distribution, but I do know a lot of you prefer FOIL. So I'm going to do some using FOIL and some using a double distribution. All right. I'm going to start with the double distribution. So the double distribution basically treats that second piece, I should have done a lighter yellow, but it treats it as one term. So what we'll have, is x times the x minus 2. So I'm taking all of this first to that x. So I have x times x minus 2. And then a plus. Now I'm going to take it all to the second term. 5 x minus 2. So we're basically distributing that term, x minus 2, as one whole unit. It's actually two terms, but we're going to think of it like a package that's getting passed to the x and it's getting passed to the 5. In other words, we're distributing that x minus 2 to both of the terms inside that first set of parentheses. But what happens is we now need to distribute again. So now I need to distribute this x to both the x and the minus 2. That's going to give me x times x, which is x squared, x times a negative 2, which is a negative 2x. Then I have a 5 times x, which is 5x, and a 5 times a negative 2, which is minus 10. Now I want to look at this and see, is there anything that can be combined? And yes, there is. I can take this minus 2x and this plus 5x. They are like terms, and I can mush them together. I can combine them together to get x squared plus 3x's minus 10. It's not a red box, but you get it, right? I'm able to put them together like that. Do you want to try it again? Okay, let's try it again. All right. Should we do 8? Yeah, let's do problem number 8. I feel like this went a different direction in terms of numbers, but maybe not. All right, so if I'm doing this for number 8, I'm going to use the lighter yellow because I think you can see through it a little bit better. I'm going to take this 3a plus 9, and I need to distribute it to the 2a and to the minus 1. Didn't quite work that way. Okay, so I'm going to have a 2a. It's a very lemony yellow. And I'm going to multiply this 2a by this whole set of parentheses, 3a minus 9. Oh, plus 9. Ooh, good call. Can't see it at all, can you? 3a plus 9. There we go. And then I'm going to take and distribute it to the minus 1. So I'm going to have a minus 1. 3a plus 9. Okay. But what happens is I still have a set of parentheses. So now I need to distribute that 2a to everything in this parentheses. So 2 times 3 is 6. A times a is a squared. A to the first plus another, so that's a squared. Then I have 2a times 9. So 2 times 9 is 18. Nothing is a. Distributing that negative 1, I'm going to have a minus 3a minus 9. Then I can look for my like terms. I'm telling you, they almost always fall in the middle. And I have a 6a squared plus 15a minus 9. Okay, double the distribution. Can we mix it up slightly? Yeah, you can do it a little bit differently. You can, some of you may prefer to actually distribute this guy. So you can distribute the front one. I'm going to go back to the yellow here. You can actually distribute this guy to both of them. So we have a 2x, and then we'd have a 1/2 x minus 8. And then we can distribute this to the other one, minus 8, 1/2 x minus 8. And this will work too. I'd have a 2 times a 1/2, that's a 1. X times x, which is x squared. 2 times a negative 8 is a minus 16. Don't forget the x. Negative 8 times a 1/2. Half of 8 is 4. So it's a minus 4x. And 8 times 8, negative times negative, that's 64. I know it's not 16. 8 times 8 is 64, not 16. I should have some like terms. So this is going to give me x squared. Oops, I'm off the grid. X squared minus 20x plus 64. And that's double distribution. Okay, you can do it in either direction. People tend to fall in a pattern. Just find your pattern and stick with it. Okay, the second method is known as foiling, or first, outside, inside, last. FOIL is an acronym that stands for the first terms. The O stands for multiplying the outside terms. The I stands for multiplication of the inside terms. And the L stands for multiplying the last terms. Okay, so I'm going to use my colors. Okay, this might look a little messy. I'm just going to forewarn you. Okay. When we're multiplying the first terms, that means I'm going to take the 9x and I'm going to multiply it by the 2x. These are the first terms. Those are the first terms in each of the polynomials, or in each of the sets of parentheses. So the 9x is the first term in the first set of parentheses, and the 2x is the first term in the second set of parentheses. Then we want to do the outside terms. So the outside terms are the penguins that get cold. They're the terms that made no sense to you, only to me. But the outside terms are the ones on the furthest outside. So that would be the 9x is on the outside, and the other term on the outside is the 3y. So if we did 9x times the 3y, those would be the outside. Okay. The inside terms are the terms that are inside the parentheses, but they're the ones that are closest to each other. So those would be the inside terms, the minus 2y times the 2x. Those would be the inside. And then the last terms would be the last term from each of the, there we go, the last term from each of the binomials. So that would be the 2y times the 3y. The negative 2y times the 3y. Those would be the last. Okay. There it is, all written out. I've taken a moment to write it out and figure it out for you. So if I do the 9x times the 2x, that's 18x squared. Plus the outside would be 9 times 3, which is 27. And then I'd have xy. The inside would be a negative 2 times 2, or a negative 4. And again, I'd have an xy. It's okay that I changed that order. Then my last would be a negative 2 times 3, or a negative 6y squared. I should have some terms in the middle. Oftentimes, they are the ones that will combine. So I have an 18x squared minus 27x, or plus 27xy, minus 4xy. Wait, is that? No, it's not. Thank you. Okay, so that would be a minus 3. I knew something was up. So that would be a minus 27. 2 and 2, and this would be a minus 3, so that would be a plus 6. Glad I caught that one. So that would be an 18x squared minus 31xy's plus 6y squared. And that's first, outside, inside, last. So the first, and then I used this lovely blue for the outside. For the inside, I'd use the red. And for the last, I used the pink. Okay, so let's maintain those colors and see what I can do. All right, ready for number 11? So if we use the FOIL method for problem number 11, we would be taking our first terms, that's orange. So I would be a 0.2m times the first and the other one, which is a 0.8m. My outside would be the 0.2m times the 2.8, because those are the two on the outside. The inside would be 1.5 times 0.8m. Oh, and I ran out of room. I gotta do the last in pink. And my last one would be 1.5 times 2.8. So that's going to be 0.16m squared plus, that's 2.8 times 0.2. I want to say that's 0.56. Decimal places, 0.2 times 2.8. Yep, 0.56m plus 1.5 times 0.8, 1.2m plus 1.5 times 2.8 is 4.2. Want to make sure I get those numbers right, especially after the last time when I didn't get them so right. All right. So this is 0.16m squared plus, I can combine those, 1.2 plus 0.56, 1.76m plus 4.2. Okay. There we go. I should have red boxed that one. All right. Now, I just want to point out that a lot of people use FOIL because they don't need to write all these out all the time. So most of the time what they'll do is, often using mental math, they'll do the first. So 2/3 v times 1/5 v would be 2 times 1. So I've got 2/15 v squared. That's my first terms. My outside would be 2/3 of 9, which is 6v. My inside would be 1/5 of 10, or minus 2v. And my last would be minus 90. 9 times 10 is 90. Or 2/15 v squared plus 4v minus 90. Now, in no way, shape, or form do I expect that everyone will be able to do this fast. At least not as we're going through it right now. Maybe you could. But these are the two different methods. The foiling method is just an acronym to help you remember. You don't need to show all this work every time. The double distribution gives you the same terms as would occur in FOIL, but it just doesn't have a fancy name. Both of these are fine methods. It does not matter to me which one you use. Just pick one that works for you and stick with it. All right. Now, this particular section is going to go over some of the patterning that happens. We're going to talk about 3 of the most basic patterns when you're multiplying binomials, and that's the square of a sum, the square of a difference, and what happens when you not produce, but when you find the product of a sum and a difference. All right? So what does that mean? Well, here's a very common mistake. If we're doing x plus 6 squared, keep in mind that this is x plus 6 times x plus 6. There is no shortcut for this that is just x squared plus 36. That doesn't work. Don't do it. Don't do it. This is x plus 6 times x plus 6. And from here, we can FOIL or we can double distribute. I'm going to FOIL. That's going to give me x times x first. Outside will be 6 times x. Inside is also 6 times x. And the last is 6 times 6, or 36. This gives me x squared plus 12x's plus 36. If I do a second one like this, I see z plus 3 squared. That's z plus 3 times another z plus 3. I haven't talked about it, I don't think, but I put my lines through my z's because my 2's, as you notice, also look like z's. So a common workaround for that is to actually put a line through the letter. If you go to a four-year college, you may, or if you go to somebody who has not necessarily been educated here in the US, they will often call z's Z, and they're almost always written with a line through them. So if you're ever in another math class and someone starts talking about a Z, that's just the way that they say Z in some cultures. So Z quite often has a line through it to indicate its difference from a 2. That's why I do it. Little moment there we have. All right. So I'm going to use FOIL again. The first would be z times z, or z squared. The outside would be 3z's. The inside would be another 3z's. And the last would be 3 times 3, or 9. So the two middle will combine, and I will have z squared plus 6z plus 9. Okay. If I have x plus 8 quantity squared, this is going to be an x plus 8 times another x plus 8. Using the FOIL method, the first would be x times x, or x squared. The outside would be 8x. The inside would be another 8x. And the last one would be 8 times 8, or 64. When I simplify this, I have an x squared plus 16x plus 64. Now, each one of these, there is a pattern. I'm not going to tell you what the pattern is. I'm not going to tell you what the pattern is, but I do want you to watch for it. Okay? What happens when we square a difference, when we have a binomial that is the difference of two numbers? So here I have x minus 6, and I'm squaring it. I know from the previous problem that x minus 6 squared should be rewritten as x minus 6 times an x minus 6. It's in this section about multiplying polynomials and foiling and double distribution because I need to use that